All right, we can use this idea of critical points, max and mins, to help us with some applications out of the real world. So what we're going to look at are 4 common problems that you're going to run into, and what I would do is take these notes and use them as you work through the worksheet for the section. So one of the more common ones is when we take a rectangular situation and either we want to put fencing or something around it. What we're basically talking is perimeter. Now what they'll do once in a while is throw at you that there's a barn in this case or something that we're going to put the fence around. So what I really need then is a width, a length, and a width. Okay. And what they're saying here, use the amount of fencing to write an equation in y equals. I don't do that. What I do is I talk about perimeter. Okay, so the perimeter that I need to fence in this case, I have 50 meters, but what it is 2 widths and 1 length that I need to cover. Okay. Occasionally they may talk about a situation where you have a fence down the middle, which then in that case would just change this to 3 widths. Okay, but since we're just dealing with the 2 here, okay, we're not going to look at that. All right, and so what we do with that then is eventually we're going to get to a point where we need to get an equation in terms of one variable. So what I'm going to do is rewrite this with one of my variables all by itself. And in this case, it's easy to see that the easy one to get alone is the length, because then I don't have to do any division. Occasionally when we have to divide, you may end up with fractions. Okay. All right, once we've done that, what we're looking at now is we want to maximize the area. Okay, and that's the function that we have to be concerned about, because that's the one that down the road we're going to take the first derivative of. We're going to find the critical points for. So don't think of it as x times y, think of it as length times width. And so what we have is that my area equals my length, which I've just renamed as 50 minus 2w's, times my width. And if I distribute my w, I'm at 50w now minus 2w squared. And so like I said, we're trying to maximize area. So what I'm going to do is I'm going to take my area and take the first derivative. So a prime will give me 50 minus 4w. And if you remember from when we dealt with the graphing part of it, what we do to find those max and min points is set that derivative equal to 0. And so when we do that, we'll have 50 equal to 4w, and then we'll have w equals 12.5. So the width of my garden then, when I maximize it, would be 12.5, what are my dimensions? Meters. Okay. I can find my length now by going back to the equation that I isolated my length and find out that my length is 25 meters. And so now that maximum area I want to deal with, length times width again, 25 times 12.5 will leave me a 312.5 square meters for that maximum area. Okay, so just a quick review. You're going to try and write either length or width in terms of the other variable, multiply your length times your width, okay, get that area equation, take the first derivative, set equal to 0, and then find the things that we need to answer the question. All right, second type problem. We got a fruit grower who wishes to ship early in the season when prices are high and spoilage is low. Right now he's got 15 tons, and he figures that each week he's going to get 3 tons more. He would make $300 per ton right now. He estimates that his profit will go down $20 each week. So the situation here is what I'm looking at is maximizing profit. So thinking ahead, I need to come up with an equation for profit that I'm going to be able to take the derivative of. Okay, how we figure out profit? It's how much I have times how much I make. Okay, so it says write an expression for the items, the amount. Okay, should say items times the amount. In this case, fruit. Okay, so what we can think about, my profit right now, today, would be 15 That's how many tons I have times the 300, okay, which would lead me to $4,500. Now, if I wait a week, I'm going to be able to add 3 more ton. Okay, but the price is going to go down $20. Okay, so then I would 18 times 280, or $5,040. And I could do that again. I could come up now if I waited another week, so 2 weeks. Now I'd be adding 6 ton, but my cost per ton is going to go down another 20, so it'd go down $40. I keep doing that and doing that and doing that. Okay, but the problem is I want to know how many weeks I should wait. I don't want to just play guess and check because I may never actually come up with the actual value because it could be some time during midweek. So what I'm going to look at is I'm going to identify my variables, W. It's the number of weeks that I should wait. And like we saw here, I had 3 and then I had 6, then I had 9 that I'm adding on to my 15. So I don't know how many, but each week, so whatever value I pick for W, I'm going to multiply that by 3, and that's how many tons I'm going to add to my storage. Okay, but at the same time, when I go in, I'm going to lose 20 times whatever number of weeks. All right, so same idea. What I'm going to do then is get that profit function. So I'm going to multiply this all together. Okay, I'm just going to go to it right away, and then you can check it to make sure I did my work correctly. Okay, that's my equation that I'm writing. Now, what I want to do is I'm all the way down here already to number 4. I'm going to take the first derivative. I'm going to do that up here so I have some room. Okay, derivative of a constant, so 4,500 is 0. 600 minus 120W. Okay. Set that to 0. So 600 equals 120W. And so I should wait then 5 weeks before I sell. Okay. Now, go back, plug that 5 weeks in for W. And what you do when you find that out is that you're going to have a profit of $6,000 max. Okay. Now, other types of problems you'll see with this would be a situation like if I have tickets, if I decide to raise my ticket price by a certain amount, I'm going to lose a certain number of people coming to games and things like that. So those are other types of problems you would use this example for. All right, third one. This is a physics situation where they're going to give you an equation, so it's actually quite easy. Okay, but a couple things I want to point out is when you look at your equation, if I were asked to write this equation, it's actually fairly simple because what happens is my initial velocity of 112 feet per second, that's how hard I throw this stone. Okay, that's always your linear piece when you write this equation. The 700 feet, that's your initial height. Okay, so I'm starting 700 feet above the surface. That's always going to be your constant. This last piece here, this negative 5.6, that's acceleration due to gravity. And so obviously gravity on Mars is 11.2 feet per second. On Earth it's 9.8 meters per second, 32 feet per second. We cut those in half when we write these equations. So if you get into a physics, you'll see this again. But the nice thing is, like I said, they already gave you the equation. All we got to do now is take my first derivative, set it equal to 0. Okay, so when I take the first derivative of my height function, 11.2t plus 112, set it equal to 0. Okay, actually it's a negative 11.2t, sorry. 11.2t then equals 112, and then t is going to be 10. So 10 seconds to reach that max height, okay, because t is time. Take that 10, plug it into my equation, and what you're going to find out is that that max height then is 1,260 feet above the surface. So like I said, this is a simple case where they give you the function already, and all you have to do is take the first derivative and go clean it up and find the solution. All right, sum difference of numbers problems. Okay, what we're going to do is we're going to have 2 or 3 numbers that we're going to add, subtract, maybe multiply. Okay, but what we got to do again is like we've been in a couple of situations, like the first one again, get one of my variables in terms of the other, in terms of just one variable. So here we got 3 numbers. Okay, I'm going to call my first number x, excuse me, second number y, third number z. Okay, and what I want is a situation where the first is equal to the sum of the second and third. So my first number is what I get when I add the second number y and the third number z together. Your second number is the square of the third. So my second number y is the square of the third. Okay. So what I want to do again is get everything in terms of one of these variables. Well, hopefully what you notice is that I got a z in the third number, a z in the second, a z in the first. So that might be what I'm looking at. And so what I can do is I can rename y z squared and then plus z. Okay. All right, now write our equation. So what I'm trying to do is I want to find the sum, so that's addition. So I'm taking my x plus my y plus my z. And I like to have an equation, so I'm going to call it s, or sum, equals x plus y plus z. Okay, well, again, we tried to get everything in terms of one variable. So my x, now I'm going to call it z squared plus z. My y, z squared, and then my z, obviously, is z itself. So where I'm at now with my equation is 2z squared plus 2z. Okay. This time I'm actually going to minimize. Okay. So I'm still going to go about finding the first derivative. And then I'm still going to take that first derivative, set it equal to 0. And when I divide both sides by 4, I get negative 1/2 for z. Y then is z negative 1/2 squared, okay, which becomes 1/4. X becomes y plus z. Okay, so I'm going to add those two together, so I get negative 1/4. Okay. So my 3 values that I found, x plus y plus z, that sum that I get, that minimum is negative 1/2. When all of these rules hold true. All right, so hopefully these notes will be able to get you through that worksheet for word problems.